Guys, in this video we will discuss a t-test in three different cases: independent sample t-test, paired sample t-test, one sample t-test. And the first two cases there will be two different samples. See the first case, two different samples which are independent for one variable. Okay. Second case, there will be two variables for one group. You can say that the first case of independent sample test, we can test the performance of two different classes, whereas in paired samples t-test we can test the performance or improvement of the performance of one class students by conducting two consecutive tests, right? So this is paired sample means data of one group will be analyzed. In the previous in the independent sample test, there will be two different data for one information, isn't it? And third case, there will be only one sample test, one sample which will be compared with the population mean to verify whether this sample represents the population or not. Okay, let's go to an example. Here, example 1, a study of the effect of caffeine on muscle metabolism used 18 male volunteers who each underwent arm exercise tests. See, this 18 is not sample. There are two different samples. 9 of the men were randomly selected to take capsule containing pure caffeine 1 hour before the test. The other 9, so one sample of 9 men and the other sample of 9 men, isn't it? One sample consumes caffeine, the other sample consumes placebo before the arms exercise test, isn't it? During each exercise, the subject's RER, respiratory exchange ratio, was measured, and the question here is whether there is any difference between the performance of caffeine and placebo. So obviously our null hypothesis will be, see here SPSS default uses two-tailed test. Okay, if you want a one-tailed test, we should adjust the data slightly. It will be a default two-tailed test. If at all you want a one-tailed test for confidence in level 95%, if you want a one-tailed test, then set the confidence level as 90% in SPSS, and then at the end find significant level divided by 2. You will get significant level in the table, divided by 2 and take it as p-value. Then compare with the alpha, which is 0.05 for 95%. Then take a decision. This is what we should do for one-tailed test, but we are going to do only two-tailed test here. Okay, fine. The two-tailed test is assuming that they are performing the means of the two samples are equal as our null hypothesis, and alternate hypothesis they are not equal. Okay, now there are two groups, placebo consumers and caffeine, isn't it? We will collect this data in SPSS. It's already collected. I will show you this here. It's listed here. The first column I'm going to variable view. First column is capsule. Second column is RER, respiratory exchange ratio. So there will be RER data for two groups. First group is capsule. Second group is first group is 1 and second group is 2. We must know that in the variable we can see in values, 1 is given value is placebo and 2 is caffeine, isn't it? So 1 is representing placebo consumers, 2 is caffeine. Okay, now remember this one and go to data view. Let us perform the independent sample t-test. Go to analyze, come down, compare means. We are comparing means. Here you can find all the three tests: one sample t-test, independent sample t-test, and paired sample t-test. Go to independent sample t-test, select this one, set, and here which is the testing variable. We are testing this one, RER is the testing variable, the data for the groups, and the groups are two, group 1, group 2. There are two different groups. One is representing placebo and 2 is representing caffeine. So this capsule is grouping variable. move it here. And define groups, select this define groups. Now group 1 is group 1, group 2 is group 2. Okay, because I given numbers for group and then gave values as placebo and cafe. Okay, continue. In the options you can see default 95% confidence interval will be there, right? Continue. You can give OK. Give OK. In the output page you can see independent sample t-test. See, there are some statistics here. We just one significant level SIG is here, you can see, which is 0.663. So 0.663 we can compare with alpha, and our alpha for 95% alpha is 0.05. Okay, so our p value, which is 0.663, greater than alpha, therefore we will accept H0. Okay, that is the conclusion here for this problem. The conclusion is that there is no difference between the performance of caffeine and placebo. That's it. Next we will see the second case, paired sample test, paired sample t test. Okay, suppose a sample of 20 students were given a diagnostic test before studying a particular module and then again after completing the module. So one group two different test data. Okay, we want to find out in general our teaching leads to improvement students' knowledge skills. Now we use the pair test, one sample, two different data, isn't it? So go to this. The assumption is null hypothesis, H0 is D equal to 0. There is no difference. That is mu1 is equal to mu2. Or alternate hypothesis, D not equal to 0, mu1 not equal to mu2. And the data are given below. Here you can see the data. Students pre-module test score and post-module test score. Okay, these data are listed here. Now I can show you this one. Paired, see, students ID 20 students, pre-module test and post-module test, two different tests. Now whether there is any improvement in the students' performance or not, again go to analyze. Compare means paired sample t test, select this one, and you know the paired variable 1, variable 2 for one pair. Pre-module will be moved to variable 1 and post-module will be moved to variable 2. Now in the options you can find default 95% confidence interval. Give continue and now just give OK and go to the output page. You will see the paired sample t test statistics here, and in the third table, paired sample t test third table, you will find SIG value here, two-tailed SIG value 0.04. Compare with the alpha value and write the conclusion. That's all. So the alpha value for 95% confidence level, alpha value is 0.05, and our significance level p value what we got here is 0.04. So comparing this one, p value is 0.04, which is smaller than the alpha, and therefore we reject H0. What is your H0? There is no difference. Both the tests are in the student. There is no improvement in the performance. That is H0. It is rejected. So there is improvement in the performance of student. That is what alternate hypothesis. So that is it. And third part of this one is one sample test. We'll see one sample test. One sample t test is shown here. A sample of 10 leaves has shown Lee weights. So all these are Lee weights for 10 leaves. On the basis of our results, can we say that this sample is selected from the population having mean? So this is mean leave weight 15 units. So this population mean is 15 units. So we are going to compare the sample with the population. So our null hypothesis mu is equal to 15, and alternate hypothesis mu not equal to 15 at 95% confidence level. Okay, and this data should be entered in SPSS. It's already entered here, and you can see. Now again go to analyze, compare means, one sample t test, and this length of is a testing variable, and test value is the population mean, which is 15 in this problem. You can find it here. 15 mu is 15. This is the test value, so that is entered here. There you go. You can find this, right? In the options you can find default 95% confidence interval. Give continue and give OK. In the output page there will be one sample t test appearing here. Here look for the zig value, that means significance level. Alpha compares, there is p value that is to be compared with alpha value. This 0.947, very bigger than 0.05, isn't it? So for again alpha value is 0.05 for 95% confidence level, isn't it? And here the p value what we found from the conclusion from the output table is 0.947. 0.947, which is bigger than alpha. So what we do is accept H0. It means mu is 15. This sample is from the same population of mean weight 15. The sample is representing that population. That's the conclusion. This is the way all the three tests are performed. Thank you very much.